class. So it appears my live lecture didn't actually end up recording, and I deeply apologize that. So I'm going to get out this equation here with working with your problem that we have for the week 6 module. Okay, so just really fast, live lecture question. That is going to be, what was your favorite module and why? Okay, so what was your favorite module, 1 through 6? Which one was your favorite and why? And to be honest, if none of them are your favorite and you're just glad to be done with the class, you can tell me that too. I totally get it. But yeah, so here we go. Last ever lecture for college algebra. So again, we're just going to go over a very similar question that looks like your written assignment. Okay, so here's your scenario. Your donut shop has perfected a method for the perfect glazed icing by slowly mixing whole milk to confectionery sugar while exposed to low heat. Your mixing tank starts with 12 fluid ounces of milk and 12 ounces of sugar. You continue adding sugar at a rate of 10 ounces per minute and milk at 1 ounce per minute, as depicted by the two equations below. Okay, so here we have our two equations. So we have our sugar and we have our milk. Okay, so again, these are different from what you have. This is an old example. So again, you probably will see this online if you're looking out online. So if you use these numbers, that is an automatic 0. Okay. So where S represents the number of ounces of sugar, M represents the number of ounces of milk, and T represents time in minutes. So the ideal icing will have a ratio of 8 ounces of sugar per ounce of milk. Okay. So let's go ahead and look. So show and explain all steps in your responses to the following parts of the assignment. All mathematical steps must be formatted using the equation editor. Okay, so part 1, create a rational equation to represent the concentration in ounces of sugar per milk. Okay, so one of the key things with that is you want it in sugar per milk. Okay, so that's what we're going to write, and I'm going to show you why I'm writing this. So this goes back to that module 2, that per, okay? So your concentration is sugar per milk. Remember, per is just another way for a rate of change, which is a fraction. Okay, well, my question is, do we know the equation for sugar? Do we know the equation for milk? We do. That was given to us in the beginning. Okay, so again, we were given those equations, so now we're going to fill it in. So the sugar was 10 plus 10t. And then the milk was 10 plus 1t. Okay, that's it. That's all you have to do for part 1. You're just writing that equation. Okay, the next part, part 2, find the domain of the concentrate equation. So the domain of the concentration equation is all values of t, except for those that will make the denominator equal to 0. Okay, so remember, we can't have 0 in the denominator. It doesn't exist. So to see if there's any place where the denominator could go to 0, what you're going to do is you're going to take what you have in the denominator. So in this case, just looking here, that's in our denominator. So 10 plus 1t, and I'm going to set it equal to 0 because I want to know, is there a place where it's going to 0? Well, now we're going to solve. I'm going to subtract 10. So t, and it says 1t, you can just put t is equal to negative 10, okay? So the domain of the concentration equation is going to be all real numbers where t cannot equal negative 10, because remember, at negative 10, if I were to plug this back into your equation, I'm going to get a 0 on that bottom, okay? So then to write my answer, okay, again, because we want to write those formal answers, so the domain of the concentration equation is all real numbers, because again, it can be any number. It can be negative 50, it can be negative 100, it can be 1 million. All those numbers are going to work, okay? But we cannot have all real numbers, okay? Except t cannot equal negative 10. Okay, so this is my answer here. So it's all real numbers except t cannot equal -10. So that's all you have to write for that. That's my domain. Part 3, okay? So part 3 says, will we encounter a time where the rational equation is undefined? Explain your reasoning. Okay, so right now we know from the domain, at -10, our function's undefined. So if you were to graph that, what's going to happen is at -10, you're going to have that vertical asymptote going on. But here's where the kicker is. Okay, this is where you guys got to think, because this is a real problem. So we're talking about time. So they're saying at time -10. Can we have -10 minutes? No, time starts at 0. Okay, so there is no place where the concentration equation is undefined. Okay, so that would represent the time 10 seconds before mixing. So the equation will work for all values of t what we would realistically need. Okay, so is there a place? So the only place where there is, okay, again, just writing this. So the only place where it's undefined is -10. Okay, so this is where it's undefined, is at -10. But because we're talking about time, okay, you can't have that negative time, because that, again, that would represent time 10 seconds before mixing begins, which doesn't make sense because you can't have something before. Okay, so the answer here is no for what the reasoning I gave there. Okay, let's go to the next part. So calculate the equation after, or the concentration after 5 minutes. So after 5 minutes of mixing, what is the concentration right now? Okay, so again, that's what I'm going to do is I'm going to bring up my equation that we have. So our equation, again, was that 10 plus 10t over 10 plus 1t, or just t. Well, we know t is going to equal 5, so now we're just going to plug it in. So where I see a t, I'm plugging that in. Well, 10 times 5 is 50. 50 plus 10 is 60. And then 10 plus 5 is 15. So 60 divided by 15 is 4. Okay, so my concentration is 4. Okay, I can't just leave it at that because that's for what? Okay, so then my answer here, so the concentration is 4 ounces. Okay, because again, we're talking about ounces. Put an extra 0 in there. Ounces of sugar per ounce of milk. Okay, and again, I know it's 4 to 1 because 4 as a fraction is 4 over 1. And remember, it's milk to sugar. So there's 4 parts milk to 1 part sugar. You just have to make sure you label it. So again, the concentration is 4 ounces of sugar per 1 ounce of milk. Oops, and I did that backwards. There we go, sugar to milk. Okay, so now let's go to the last part. So this is the part a little bit more people struggle on. So how long will it reach? Okay, so how long it takes to reach a concentration of 8 ounces of sugar per ounce of milk. So here we're using C is equal to 8 because they want to know how long to reach a concentrate of 8 ounces. So again, we're using that equation, the 10 plus 10t over 10 plus t. Well, C is equal to 8, so I'm going to plug that in. And they want to know how long, so that means I'm solving for t. Okay, so I got to solve for t. Well, the first thing I want to do is I don't like this fraction on the bottom, so I'm going to get rid of it. Remember, a fraction just means division, so what's the opposite of division? Multiplication. So I'm going to times both sides by 10 plus t. That's going to get rid of that. Okay. Now make sure you put a parenthesis here. Okay, so now on this side we just have this left because we got rid of that denominator. And the reason you have to put a parenthesis around what you're multiplying is because you have to make sure you distribute. So 8 times 10 is 80, and then 8 times t is 8t. Okay, so now you have an equation to solve. We're back to module 1. So again, personally, I just like moving my letters to the left. So I'm going to bring the 80 down. So 8 minus 10 is -2 equals 10. Subtract 80. So I have -2t equals -70. To get t by itself, we're going to divide by -2. Negative divided by a negative is a positive, so t is equal to 35. Okay, so again, I want to make sure I write this correctly. So how I'd write that is, so T is 35. So it takes 35 minutes to reach a concentrate of 8 ounces of sugar per ounce of milk. Okay, so again, all I did here was change the numbers. Yours looks identical. The questions are the same. You just have a little bit different numbers. If you have any questions on this, please let me know. Everything is due on Sunday. I will have office hours today, Saturday, and Sunday if you need me. Okay, have a great day.